A wall of water once came across eastern Washington and stripped it down to bare rock in a matter of days. That was the claim a geology professor from Chicago made in a private club in Washington, D.C. on the 12th of January, 1927, standing in front of a room full of government scientists with a map he had drawn himself. 5 summers of walking had gone into it. And when he sat down, 5 men got up one after another and took the whole thing apart. The map was the argument. It showed a plateau of black basalt, cut to ribbons, hundreds of channels braided into one another, canyons that led nowhere. A waterfall 400 feet high standing bone dry in open country, with no river above it, and nothing below. Harlen Bretz said a flood had done all of it. One flood, water hundreds of feet deep, moving fast enough to quarry solid rock, and gone again inside a week. The men who answered him were serious scientists doing their jobs. They had one question, and it was the right one. Where does water like that come from? Bretz had no answer for them. He'd guessed at one, and the guess turned out to be wrong. There was a 6th man in the room. He spoke that evening too, briefly, about something else entirely, and he had the answer in a drawer at his office. I went into this expecting one story, and came out holding a different one. The version everybody tells is stubborn genius against closed minds, and the record doesn't support it. Almost nobody tells the real one, because the flood is so enormous that the argument about it gets compressed into a single line at the end of the documentary. They mocked him, and then he was proved right. What actually happened is that the answer to Bretz's problem had already been written down by a government geologist who was instructed on paper to hold it back. He held it back for 18 years. And when it finally arrived, the version those 5 men had refused to accept turned out to be the cautious one. So what follows is the room, the memo, and the man who waited. The object that ended the argument is a set of gravel ridges on the floor of a field in Montana. You could drive past them and see nothing at all. It took until 1940 for anyone to stand up in public and say what they meant. Drive east out of Seattle over the Cascades, and the country opens into wheat. Rolling hills of it. Deep loose soil, the wind piled up over thousands of years. Some of the best farmland in the United States. Then, without warning, the soil stops. What's underneath comes up through it, like bone through skin. Bare black basalt, scoured and gouged, running in long braided tracks across the whole eastern half of the state. Local people had a word for it before any geologist did. Scabland. Bretz kept the word, and he wrote that the scablands were wounds only partly healed, great scars marring an otherwise fair face. Look closer, and it gets harder to explain. There are canyons hundreds of feet deep that carry no water and never have, potholes drilled down into solid basalt wide enough to park a house in, and gravel bars sitting up on hilltops, high above the valley floors where gravel is supposed to end up. And there are dry cataracts, cliff faces, where an enormous waterfall, clearly used to pour, standing in open scrub, with nothing feeding them. The biggest is Dry Falls, 400 feet high, and 3.5 miles from one end of the cliff to the other. The Park Service calls it 4 times the size of Niagara. Today there's a viewpoint on the rim, a couple of small lakes at the bottom, and no river anywhere. I've looked at a lot of photographs of that cliff, and not one of them looks like erosion to me. They look like the aftermath of something that came through once. Bretz first ran into the problem around 1909, while he was teaching high school science in Seattle. A new geological survey sheet came out covering the Quincy area, and he saw a cataract marked on it, a big one, with no watercourse leading down to it. He asked the geology faculty at the University of Washington how something like that forms. Nobody could tell him. He went away and thought about it for 13 years. By the time he came back, he had a doctorate from Chicago, and he was bringing students out every summer, on foot and by Model T, mapping every channel and every bar and every divide the water had crossed. He had no aerial photographs. He built the entire picture from the ground and from paper maps. And the picture does things rivers never do. The channels cross each other. They climb over ridges. They braid and rejoin hundreds of feet above the valleys that ought to have carried them. A river finds the low ground and stays in it, and the only thing that crosses a ridge is water deep enough to have swallowed the ridge whole. There was a rule in geology at the time, and the rule is what buried him. For most of the 19th century, the science had been fighting its way out of flood explanations. Every strange landform in Europe had once been handed to the biblical deluge, and the field spent decades painstakingly showing that the real agents were slow ones, rivers cutting, ice grinding, rain and frost taking rock apart a grain at a time, across spans of time nobody could really picture. That was geology's great achievement, and they called it uniformitarianism, and it worked less like a theory than like a rule of hygiene. You explain the past, using processes you can watch working today. Catastrophes weren't so much disproved as ruled out of bounds, because the moment you let one back in, there was no obvious way to stop the flood geologists walking through the door behind it. None of that strikes me as stupidity. It reads as a field guarding a line it had spent a century drawing, and guarding it in the one place where the line happened to sit wrong. So when Bretz published in the Journal of Geology in 1923, and wrote that a debacle had swept the Columbia Plateau, he was doing something larger than offering a mechanism. He was asking a science to suspend the rule that had made it a science. He knew it too. He'd been promoted to a tenured professorship shortly before, and he'd just been added to the editorial board of the journal that ran the paper. I'm not going to claim that's how it got published. I'll say he was standing in about the only position in American geology where a man could put that sentence into print and still have a career afterward. He backed it with everything he had, more than a dozen major papers between 1923 and 1932, all of it field data. He worked out that the water had swept over 400 square miles clean of the loose Palouse soil, and that the hills which vanished had averaged 200 feet high. In places the torrent cut 100 to 200 feet down into solid basalt. He traced the deposits west to Portland, where the flood dumped a delta covering close to 200 square miles. None of it worked. The objections came steadily for 15 years, and the most serious came from Richard Foster Flint at Yale, who would go on to write the standard textbooks in the field. Flint spent 4 field seasons in eastern Washington. He looked at the gravel mounds Bretz called flood bars, and decided they were ordinary river terraces chewed up by later erosion. And he explained the channels as ordinary meltwater streams that had filled the valleys with sediment and then slowly carved back down through their own fill. In 1938, he published his verdict on the whole thing. The Scabland, he wrote, was the product of leisurely streams with normal discharge. That word is still sitting in the literature. From the man whose textbooks taught the field about a country with a 400-foot dry cataract in the middle of it. Bretz's response was to keep taking people outside. When one of his loudest critics demanded a public debate at a meeting in Pullman, Bretz agreed to an informal one the next day, listened to the man restate his glacial theory, and then suggested that anyone interested should get in a car and drive out to the Scabland and look. On the way he pulled out an ordinary kitchen colander. He sifted the soil above a certain elevation, and it came through as pure silt. Below that line, out came grains of basalt and pebbles of granite that had no business being there, dropped by water close to 100 feet deep. Then he showed them the gravel bars, the abandoned cataracts, and the low hills sheared into prows by something that had gone straight over the top of them. And here is what made the other side defensible, and it's why I can't call any of this closed-mindedness. Bretz could not name a source for the water. He'd tried. In December of 1926, a few weeks before the meeting in Washington, he stood up at a conference and proposed that volcanic eruptions underneath the ice sheet had melted it fast enough to produce the flood. It was a serious attempt, and it was wrong. James Galilei, one of the 5 who spoke against him that January, did the arithmetic and showed that neither a sudden warm spell nor a subglacial eruption could put out that much water that fast. Galilei was correct. On the single most important question in the entire dispute, the critic had it right and Bretz had it wrong. Oscar Meinzer argued that a swollen Columbia River could have carved dry falls on its own, which was also reasonable on anything anyone could measure at the time. Bretz was an odd figure to be making the claim in the first place. He'd started out teaching biology and general science in high schools. He was hopeless at mathematics as an undergraduate and liked to blame it on falling out of bed as a toddler and landing on the part of his head that does maths. He held no position in the Geological Survey, which is where almost everyone in that room drew a salary. Which brings us back to the man who sat through the whole evening saying nothing about any of it. Joseph Pardee worked for the United States Geological Survey. In 1910, 13 years before Bretz published a word about the Scabland, Pardee had written a paper describing an enormous ice age lake in western Montana. Water backed up behind a lobe of the Great Ice Sheet, where it crossed the Clark Fork Valley. Glacial Lake Missoula, he called it. Around 600 cubic miles of water, held in place by a wall of ice more than 2,000 feet high. That's the answer to the question those 5 men asked, and it had been in print since 1910. The gravel ridges I mentioned are on the floor of that lake. In the summer of 1922, the same summer Bretz began his fieldwork, Pardee's supervisor sent him into the Scablands southwest of Spokane to have a look. Pardee found something out there. We know that much, because in September his supervisor, a man named William Alden, who ran the survey's Pleistocene division, wrote a memo about it to his own superior. Very significant phenomena, Alden wrote, had been discovered in the region southwest of Spokane. Then he added this: the conditions warn against premature publication. Pardee published a short note saying the area had been glaciated, gave almost no detail, and never produced the results his own preliminary report had promised. 5 years later he sat in the Cosmos Club and listened to William Alden open the attack on Bretz. The only thing Pardee said that evening was a small technical remark about how the direction a slope faces affects the way scree piles up at the bottom. That sentence in the memo is the one I can't get past. There's nothing sinister in it. Caution was Alden's actual job, and a supervisor telling a junior man to hold a wild interpretation back until it's solid is ordinary, defensible management. It was also, in this one case, what kept the answer off the table for 18 years, while the argument went nowhere. I can't tell you whether Pardee held his tongue out of institutional discipline, or out of something closer to fear. The paper trail is silent on that. What the paper trail does show is that in 1925, he wrote privately to Bretz, suggesting Lake Missoula as a possible source, and Bretz, still attached to his volcanoes, let the idea sit for 3 years before he took it up. So the 2 men who, between them, had the whole thing, were writing to each other in private, while the argument went on, without either of them. Eventually Bretz stopped fighting. After 1932, he walked away from the Scabland altogether, sailed for East Greenland on an expedition, and then spent 23 years studying limestone caves. He'd said everything he had to say, it was all in print, and he was finished repeating himself. Which is why he wasn't in Seattle in June of 1940. The American Association for the Advancement of Science met there that month, and the geology section ran a session on the quaternary geology of the Pacific Northwest. From the list of papers, the whole afternoon was going to be alternative explanations for the Scabland, one after another, none of them his. There was a field trip afterward, led by Flint. Bretz had been invited, and he'd said no. Everything he had was already published, he replied. And if the critics would just pay attention to the field evidence, it would speak for itself. Howard Meyerhoff was in the room that afternoon, and he said later that nobody in it expected a single speaker to come out in support of Bretz. For 7 papers, nobody did. They rehearsed the ice jam models and the meltwater fill theories, and argued with each other about which non-catastrophic story fit best. The 8th speaker was Joseph Pardee. He was 69 years old, 11 months from retirement, and not much of a performer. His paper was called Ripple Marks, ? In Glacial Lake Missoula. Now, everyone in that room knew what ripple marks are. You've seen them yourself. They're the little corrugated ridges that form in sand at the bottom of a stream, an inch or 2 apart, and they're one of the most ordinary features in all of geology. The size of a ripple tells you how deep the water was and how fast it was moving. In a normal stream, running at the leisurely discharge Flint's model required, they come out an inch or 2 apart, and that is the entire range. Pardee described a basin in northwestern Montana called the Camas Prairie. Across the floor of it, he said, there are ripple marks. They're built out of coarse gravel, they stand as much as 50 feet high, and the crests sit 500 feet apart. Some of the ridges run half a mile end to end. That is a streambed ripple, with every dimension multiplied by hundreds, lying in an open field where anyone could walk over it. To build one that size, you need water roughly 1,000 feet deep, moving at a speed no river on Earth produces. And I don't think there's a cleaner piece of physical evidence anywhere in this story. It is what happens when a wall of ice 2,000 feet high, holding back 600 cubic miles of water, stops holding, and then Pardee stopped. He laid out the ripples, the scoured constrictions in the lake basins, the gravel bars stranded high on the valley sides, all of it pointing at a lake that had emptied catastrophically. Then he sat down without saying where the water went after it left Montana. The connection to the Scabland, downstream over the state line in Washington, got made by the audience, in the discussion afterward. I've read a lot of Vindication stories, and I've never come across another one where the man is simply absent for it. Bretz wasn't in the building. The argument he'd started turned over in a meeting room in Seattle, while he was somewhere else entirely, mapping caves, and he read about it later. Pardee retired from the Geological Survey on his 70th birthday, in May of 1941, and submitted his full paper a few months after that. The timing wasn't an accident. Once he was out, the manuscript no longer had to pass formal review by William Alden. The rest came up out of the ground, the way Bretz always said it would. In the 1950s, the Bureau of Reclamation cut the Columbia Basin Irrigation Project across eastern Washington, and the excavations opened the Scabland gravel bars in cross-section for the first time. Bretz came back at 69 to work the new exposures, alongside a bureau engineer and a professor from Massachusetts, whose assigned job on the team was to act as skeptic for every identification the other two made. The new maps showed giant current ripples lying on the surfaces of the bars themselves. One set sat on top of Staircase Rapids Bar, on exactly the surface Flint had described in print as a river terrace. In 1965, a party of geologists, on an international quaternary research tour, drove through the Scablands together, and somewhere on that road, they sent Bretz a telegram to tell him they were all catastrophists now. The last correction was his own, and it's where the whole thing turns over one more time. In 1969, he published a paper renaming it, no longer the Spokane Flood, singular, the claim 5 men had found too extreme to sit still for. It became the Missoula floods, plural. The evidence is stacked in canyon walls across southeast Washington. In the 1980s, Richard Waite worked a section at Burlingame Canyon in the Walla Walla Valley, where the flood sediments lie in rhythmic beds, one on top of another, each bed a separate flood. He counted 39 of them. The lake had filled behind the ice dam, burst it, drained, and then the glacier had crept back across the valley and done the whole thing again, over and over, for centuries. That landscape has had one more career since. When Mariner 9 sent back the first close images of Mars in the early 1970s, they showed enormous channels carved into the surface, and the closest thing to them anywhere on Earth is eastern Washington. Victor Baker took the Scabland work to the comparison, and in 1978 he published a paper in Science laying the two side by side. The title was The Spokane Flood Controversy and the Martian Outflow Channels. Now, I don't want to hand you a tidier picture than the literature actually has. Waite's 39 beds point to about 40 floods. The most recent synthesis, published in 2020 by James O'Connor, Victor Baker, Richard Waite and their colleagues, puts it at dozens, and probably more than 100. And the live argument in the field isn't whether there were many, it's where some of the water came from. One line of work holds that parts of the western Scablands were scoured by outbursts from the ice sheet over in British Columbia, rather than from Lake Missoula at all. There are other loose ends. Bretz spent years wrong about the mechanism, and the man who corrected him at the 1927 meeting was doing good science. Galuli's arithmetic held up. Bretz had the number of floods wrong too, and his critics were right that a single event on that scale had no plausible source. What he had was the landscape, and he read the landscape correctly when nobody else would. That counts for a great deal. The single flood he spent his career defending never happened. Pardee is harder. He had the source in 1910 and the field evidence in 1922, and he waited until his pension was secure. 18 years of an argument that could have been shortened. Alden's memo is the only paper anyone has, and it says caution, which is what a supervisor is paid to say, and which in this one instance shut the door on the answer. The field didn't rush to make amends either. Flint's 1971 textbook, the most widely used book on glacial geology there was, gave the Channeled Scabland one sentence, 48 years after Bretz's first paper. He did get the medal. In 1979, at 97, the Geological Society of America handed Bretz the Penrose Medal, the highest honor it has. In his written acceptance, the last thing he ever published, he said that perhaps he could be credited with reviving legendary catastrophism and challenging a too rigorous uniformitarianism. He died 2 years later, at 98. Does the record fix itself in the end? It does, and slower than anybody would like, and only because people keep going back out to the ground. Nobody won this by arguing. What ended it was gravel. Ripples 50 feet high in a Montana field, and a set of them lying on a bar in Washington that a Yale professor had already published as a terrace. What I keep coming back to is that September memo. 7 words, entirely reasonable, and they cost the field 2 decades. Nobody in this story sets out to bury anything, and there's no villain in it anywhere, which is the part I find uncomfortable. Because what slowed everything down was ordinary caution doing its job. Go and stand at Dry Falls sometime. There's a viewpoint on the rim off Highway 17, south of Kool-Aid City, and you can look out along the cliff where the whole of that water once came over. Then you notice what's actually in front of you: sagebrush, 2 small blue lakes, rock, and wind, and nothing else at all. It's been dry for 13,000 years, and every piece of evidence Bretz needed was lying out on the ground the entire time, which is what makes that room in Washington hard to shake. 5 men, in a club on a January evening, taking apart a map. Not one of them had walked the ground, and William Alden, who spoke first, said as much himself. And sitting among them was a man from the survey, with the missing half of it in a drawer, who raised his hand that night to make a small point about scree. This channel exists for arguments like that one, where the answer was sitting in somebody's filing cabinet, and it took 40 years and a field full of gravel to get it out. Subscribe, and I'll go and find you the next one.